Latency spiked from 50 ms to 12 seconds, then 502s after just 300 users. The culprit: Flask sync workers blocking on I/O. Let's break down FastAPI versus Flask versus Django, when to use which, how it works, and the exact mistake behind that failure. FastAPI is built on Starlet and Pydantic for high-performance async APIs. Flask gives you a router and debugger. Everything else is your choice. Django ships with an ORM, admin panel, authentication, and migrations out of the box. The fundamental difference is how each framework handles the contract between client and server. FastAPI uses Python type hints for automatic validation and docs. Flask uses loose dictionaries. You write your own checks. Django uses structured serializers. Here's the same endpoint in all three frameworks. FastAPI's type hint automatically validates and generates Swagger docs. Flask requires manual checks. Django DRF uses a serializer class, more structure but more boilerplate. Flask and Django run on WSGI. Each request ties up a worker thread. FastAPI uses ASGI and Async IO, so one process can handle many concurrent requests while waiting on databases or APIs. But Async only helps IO-bound tasks, not CPU-bound ones. Django's built-in ORM, admin, and auth let you have a working backend in an afternoon for standard CRUD. Flask gives you freedom, but you'll add extensions for everything. FastAPI reduces API boilerplate with Pydantic, but you bring your own ORM and auth. FastAPI containers are smaller because you don't need Django's ORM or admin code. Its stateless design and async workers make it natural for Kubernetes auto-scaling. Django's settings. Pi can become a nightmare in microservices. Sometimes you outgrow a framework. The migration path from Flask to FastAPI is often easiest. Both are minimal. Keep business logic decoupled from the framework so you can swap the thin layer. Django owns the monolith, auth, admin, ORM. Flask is your Swiss Army knife for small services. FastAPI is for the API-first world where latency matters. Match framework scope to project scope. Here's a quick rule of thumb. For a simple health endpoint, FastAPI is clean. For a full CMS, reach for Django. For webhooks and small apps, Flask fits perfectly. Flask looks simple, but production apps require blueprints, extensions, and context management. Django has a steeper initial climb, but once you learn its patterns, they apply everywhere. FastAPI seems easy until you hit async transaction management. FastAPI's auth takes 10 lines, but you built it from scratch. Django gives you sessions, CSRF, and password hashing in 5 lines. Flask's 3-line route is simple until you need a database. Flask jobs are often entry-level. Django dominates enterprise Python roles with stability. FastAPI roles pay 20–30% more because engineers who understand async production debugging are rare. Here's a quick data class showing average salaries. FastAPI leads in both pay and growth. Django is solid middle ground. Flask is lowest, but still a good starting point. This is the same issue we highlighted at the start. Here's exactly why that happened. The Flask app used Unicorn with sync workers. Each request held a worker thread while waiting for the ML model to run. At 300 concurrent users, all workers were blocked, new requests queued up, and latency spiked to 12 seconds before returning 502s. Flask's WSGI sync workers blocked on I/O, holding a worker thread per request until completion. Switching to FastAPI with Unicorn's ASGI async workers allowed concurrent I/O without per-request threads, handling 2,000 concurrent requests on the same hardware. The fix was switching to FastAPI with Unicorn's ASGI workers. Async handlers allow the event loop to handle other requests, while waiting on I/O. The same hardware now handles 2,000 concurrent requests with under 200 MSP99 latency. A common trap: teams move to FastAPI but keep using synchronous database drivers like SQLite 3. This blocks the event loop, nullifying async benefits. Always use async drivers like ASGI or Async. This is the exact mistake from the incident, using Unicorn with default sync workers for an I/O-bound app. The fix is to use async workers, unicorn k unicorn workers, unicorn worker app. The article mentions using async drivers like async, but doesn't note that SQL Alchemy 2's async support requires async def endpoints and async session. Without these, the event loop still blocks. Ensure you use async session from SQL Alchemy. Next, asyncio and async with session begin for true async database access. The article discusses deployment, but omits FastAPI's Lifespan Context Manager for managing resources like database connection pools. This is the modern replacement for app on event and ensures proper cleanup. The article's incident postmortem highlights sync worker blocking. A key production caveat: ASGI servers like Unicorn have different error handling semantics. Unhandled exceptions in async handlers can crash the entire worker process, whereas WSGI workers typically recover. Always use middleware or exception handlers to catch and log errors gracefully in FastAPI. To diagnose latency spikes, first check your worker type. Use unicorn k unicorn workers, unicorn worker for async. Profile your app to see if I/O wait is above 30%, and always use async database drivers with FastAPI. Let's run through some common interview questions. WSGI versus ASGI trade-offs. WSGI blocks on I/O, ASGI handles many concurrent requests efficiently. How does FastAPI DI solve global object problem? Dependencies are request scoped, no global state. CMS with 20+ tables. Django for built-in admin, ORM, auth. And a few frequently asked questions. Is FastAPI faster than Flask? For I/O bound, yes. For CRUD, overhead negligible. Can I use Django ORM with FastAPI? Possible but anti-pattern, use SQL Alchemy. Does FastAPI replace Django? No, FastAPI is API-focused, lacks admin and ORM. To recap, FastAPI is for high-performance async APIs with automatic docs. Flask is for microservices where you want full control. Django is for enterprise apps with built-in tooling. Choose based on your bottleneck and team experience. Ready to go deeper? Up next, FastAPI error handling and custom exception handlers, then PySpark tutorial. Big data processing with Python, then FastAPI CLI. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.